Hello friends, this video on Redox reaction part 12 is brought to you by examfear.com. No more fear from exam. So if you see here, we have to show the possible metals that can show disproportionation reaction. Also we have to show three metals. So three metals, three non-metals. If you see in this case, it's pretty simple. If we have this figure, for example, carbon is a non-metal and it has so many states, right? More than three. So it will show disproportionation reaction. Hydrogen won't show, only two. Helium won't show, lithium won't show, beryllium won't show, only two. Boron will show, carbon will show, nitrogen also will show, oxygen will also show, chlorine won't show, neon won't show, sodium won't show, magnesium won't show, it has only two. Aluminium will show. Similarly, in this case, phosphorus will show more than two, sulfur will show more than two, chlorine will show more than two, right? And argon won't show, potassium won't show, calcium won't show. If you see, scandium will show, titanium also will show. So if you see in this case, you can see which has more than five, this more than three, it will show. So this guy cobalt will also show, nickel will also, copper will also show. So just by looking at this chart, we can tell that which element will show this proportionation reaction and which won't. So the question is, what information you can draw from this reaction? So let's see this reaction. Let's write the oxidation state for all and see what information you know. CN2 2OH minus. So first let's try to find the oxidation state of this free image of human face and then S sum. Free we can't apply, iron we can't apply, oxygen there is no oxygen, hydrogen there is no hydrogen, fluorine there is no fluorine. Then we can apply the first group there is no first group, second group no, 13 group yes we have, right? In fact 13 also we don't have. So we have nitrogen from group 15 and we know for this it will be -3 nitrogen. Nitrogen is -3, so carbon comes out to be +3. Here OH minus, O -2, so it will become +1. Here Cn minus, same thing will apply, nitrogen -3, so this will become +2. Here CNO minus, oxygen -2, nitrogen -3, so this becomes +4, right? Because 4 minus 3 minus 2 is what? -1. Here oxygen will be -2 and then it will be +1. These things we have done in oxidation state, right? How to find oxidation state. So with this, here if you see carbon has 3, it became 2. Here carbon has 3, it became 4. So if you see, carbon is both reduced and oxidized. So this is example of disproportionation reaction. So the question is, why do same reactant, that is thiosulfate, react differently with iodine and bromine? We know that iodine is weak oxidizing agent. We have studied this. And bromine is strong, right? Oxidizing. The strongest is the fluorine. We have seen that. Why? Because the fluorine F2 is not stable and this is stable, so it always try to get reduced and it will be a good oxidizing state. Similarly, if you compare bromine and iodine, bromine is a stronger oxidizing agent than iodine. Correct. Now let's again see here in this case what is the oxidation number. So in this case, this becomes -2. We'll have use the same formula. Free image of human face. I we can't use, O we have used. Then we'll use the sum formula. So this comes out to be, if you take it x, then it becomes 2x minus 3 into 2 is equal to -2. Solve this, you get x is +2. This is +2. Similarly here also it will be same thing, +2 and -2. I2 it will be 0, right? It will also be 0. Let's try to find in this using this formula, free ion of oxygen, it will be -2, and this will be, let's suppose, y. So 4y minus 6 into 2 is equal to -2. You solve this, you get y is equal to, let's become 10 by 4, 2.5. This is 2.5. Similarly, this one is -1. This is water. This is -2. This is +1. We have done this in the past, so I'm just writing it fast. And if you have doubt, you can just watch the previous videos where for the same series where we explained how to find the oxidation number. So in this case, SO42 minus, this is again the same formula, FiO, this is -2, let this be Z. So Z plus 4 into -2 is equal to -2. You solve this, you get Z as 6, right? +6. So this is +6. Here it is -1, and here it is +1. So now if you see, in the first example, I have sulfur, right, plus iodine. I am getting S4O6 to minus 2.5 oxidation state. From 2 to 2.5, iodine is a weak oxidizing state. In second case, if you see S2O3 to minus plus bromine, I'm getting SO4 to minus oxidation state of 6, right? So if you see, since iodine was a weak oxidizing agent, I got a lesser increase in the oxidation number from 2 to 2.5. And since bromine is a stronger oxidizing agent, the increase in oxidation state is more, from 2 to 6. And we have learned this, that a stronger oxidizing agent will have more increase in oxidation number. A weak oxidizing agent will have less increase in oxidation number, right? So with this you can say that this is the reason why we have difference in reaction, because bromine is a stronger oxidizing agent. So bromine will try to have more increase in oxidation number for sulfur. We have to justify the giving reaction that among halogens, fluorine is the best oxidant, and among hydrohalic compounds, hydroiodic acid is the best reductant. So we have told this actually, that if you talk about oxidizing power, so in that case, fluorine has the maximum oxidizing power, then chlorine, then bromine, and then iodine, right? And if you talk about reducing power, then you see I told that HF is the least, HCl then HBr, and the highest is HI. And why I told is because fluorine is very reactive and this is very stable, this is unstable, F2 is unstable, right? This is I told, and this is stable. So fluorine always want to form F minus, so it will always want to become F minus, so it will always be reduced and it will be a good oxidizing agent, right? It's a good oxidant. But for if you see F minus, it won't want to go to F2, so it will not be oxidized, or it won't be a good reducing agent, right? But in case of I minus, it can become I2, because I2 will not have that urge to become I. So now if you see fluorine can easily oxidize chlorine, bromine, and iodine. So I'll show you. F2 plus 2Cl minus, if you get, this becomes F minus plus Cl2. This is the reaction you get, because fluorine can easily oxidize this chlorine. Also, if you see, if you add fluorine to bromine, you see that fluorine can even oxidize bromine. Even if you add fluorine to iodine, you see that becomes 2F minus and F2. Thus, if you see, fluorine is the strongest because it can oxidize Cl minus, Br minus, and I minus. Also, let's talk about the reducing power. If you see, I know that Hi and HBr, these two can reduce H2SO4, but not this. HCl and HF, they can't reduce H2SO4, right? So with that you can tell that, yeah, Hi and HBr are stronger and HF and HCl is not that strong. Which of the following species do not show disproportionation reaction and why? See, first thing, in all these we have chlorine involved, right? And for chlorine, what is the range? Let's see that. For chlorine, we have seen the range is from -1 to 7, correct? So let's write the range. For chlorine, the range is -1 to 7. So let's see the oxidation state for all. So if it's ClO minus, let's apply the formula. Free image of human face. Free we can't apply, iron we can't apply, oxygen we can apply. This is -2, and let this be x. So with that, if you solve x minus 2 is equal to -1, you get x is equal to +1, correct? So +1, if you see, is somewhere in the middle. That means it can easily take part in this disproportionation reaction, right? Because we told that it has to be more than 3. It is 3 for all, because in all we have chlorine, and for chlorine the number of oxidation state is more than 3. The next condition that we have is, in the reactant side it has to be in the intermediate. So if you see, +1 is in the intermediate range. Let's take ClO2 minus. Same thing, free iron, oxygen we can apply. So let's put 2. Let this be y. So if you solve this, y minus 2 into 2 is equal to -1. If you solve this, you get y as 4 minus 1, that is 3, +3. So here also +3, also if you see, somewhere in the intermediate range, right? Because it is -1, not 0, 1, 2, 3, 4, 5, 6, 7, right? So 3 is also in the intermediate range. This will also show disproportionate reaction. Let's take ClO3 minus. Same thing, you try to solve and find the value of oxidation state. This becomes oxygen -2, and let this be A. So A plus 3 into -2 is equal to charge, that is -1. You solve this, you get A as 6 minus 1, 5 plus 5. So also if you see here, 5 also is somewhere intermediate. So this will also show the disproportionate reaction. Let's take ClO4 minus. Apply the formula, free iron off, that is -2. Let this be B. So B plus 4 into -2 is equal to -1. You solve for B. B is equal to +7, right? 7 is the extreme value. Since 7 is the extreme value, it won't be able to show disproportionate reaction, because it has to both oxidize and reduce. For oxidization, it has to become 8, and that is not a valid oxidation state for chlorine, right? So it won't show disproportionation reaction. Hope you understand the logic, right? See, if it has more than 3 oxidation state and the oxidation state of the reactant is in the intermediate state, it will show disproportionation reaction. So we have this reaction and we have to tell the scheme for these reactions. So if you see, N2 plus O2 gives NO, it is A plus B is equal to C form, and also if you see, A and B are in elemental form, so this is a combination reaction. Here if you see, A is breaking into B plus C plus D. If you see, PbNO3 is breaking into PbONO2 O2. So if you see, it's breaking, right? So this is this decomposition reaction, correct? Here we see NaH plus H2O gives NaOH. So if you see here, my hydrogen is getting replaced, right, with OH. This guy is getting kicked out, so it is displacement reaction. This reaction, so this reaction, if you see, is not of type combination also, not of type decomposition also, not of type displacement also, right? So let's see the oxidation states. So let's apply the same rule. free image of human face, right? Free image we can't apply oxygen, we can apply -2. So with that sum rule, it will be +4. So let's find for this. This is also -2. So with the sum rule, it will be +3. Let's apply -2 here. With the sum rule, it will be -6 +5. Correct. So now if you see from +4 it became +3, it got reduced, +4 it became +5, it got oxidized. That means both oxidation and reduction happened for nitrogen here. So it is disproportionation reaction.
Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.